They are among the most powerful bursts of radio energy in the entire universe. As we look toward the Sun, we're reminded of the immense power and energy it emits across our solar system. It's hard to imagine anything more powerful than our Sun, yet beyond our star lies a massive phenomenon that makes even the most formidable solar giants seem small. Betelgeuse is a colossal red supergiant star with an enormous size, unpredictable pulses, and erratic behavior. This star defies easy explanation, leaving scientists in awe of its power and potential. However, during research on this immense star, something alarming was discovered. Betelgeuse is visible in the night sky during the winter months in the northern hemisphere. If you look toward the constellation Orion, you can easily spot it as the reddish-orange star marking the upper left corner of the constellation's rectangle. It is one of the largest and brightest stars in the night sky, making it nearly impossible to miss. But if you've ever observed it closely, you'd notice that the star doesn't stay consistent. At its peak, Betelgeuse is one of the brightest stars, but at times it loses some of its shine. This is not just an illusion. What we see from here is actually over 640 light-years away. While this may not seem like much at first, it is an immense distance. If you could travel at the speed of light, it would still take you over 640 years to reach Betelgeuse. And traveling there in even the fastest spacecraft would take more than 12 million years, longer than the entire history of human civilization on Earth. However, distance isn't the reason for the star's fluctuating brightness. Betelgeuse is classified as a pulsating red supergiant, which means it's an aging star that expands and contracts. When this happens, it can become brighter or dimmer in the night sky. These brightness changes can occur over long periods, from tens to hundreds of days. What's even more astounding is that Betelgeuse can fluctuate in brightness from about magnitude plus 0.5 to as bright as magnitude 0, which is a huge range. These variations happen in cycles, with the shortest lasting 185 days and the longest spanning 2,335 days. Sometimes, Betelgeuse dims significantly. For example, in February 2011, it was reported to have reached its lowest magnitude in years, dimming to a magnitude of plus 1.614. While this is still relatively bright, it's noticeably dimmer than what we are accustomed to seeing from Betelgeuse. Brightness isn't the only distinctive feature of Betelgeuse. Its characteristic reddish color comes from its cool surface temperature of around 3,500 K, much lower than the Sun's surface temperature of 5,500 K. This lower temperature means that Betelgeuse emits far less energy per unit of surface area than the Sun, which is why it appears much dimmer, despite being one of the largest known stars. It's like the giant who doesn't need to flaunt its size to feel significant. Yet, don't let its relaxed nature fool you. Betelgeuse is still a massive star, around 1,000 times larger than the Sun. This is partly why it has been the subject of so much attention. Betelgeuse has been a prominent feature in the night sky for centuries. It was first identified by the ancient Greek astronomer Timon, and its Arabic name means the armpit of Orion. While early astronomers had limited knowledge about Betelgeuse, modern telescopes have allowed scientists to study the star in greater detail. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed scientists to create models of the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter/Submillimeter Array, ALMA, an advanced observatory in Chile. ALMA has provided high-resolution images of Betelgeuse's surface, unveiling new insights into the star's structure and behavior. One of the most remarkable discoveries made with ALMA is the presence of a massive gas plume extending from the star's surface. This plume, which is thought to be caused by Betelgeuse's pulsations, might help explain the star's unusual behavior and its constant changes. The pulsations of Betelgeuse are driven by a process called convection, in which hot gas rises and cooler gas sinks. This movement creates waves that travel through the star's atmosphere, causing it to expand and contract. Using Hubble Space Telescope, astronomers have captured detailed images of Betelgeuse's surface, revealing complex patterns of gas and dust. These observations have allowed scientists to create models of the star's behavior and understand how it might evolve in the future. Betelgeuse's surface is also covered in dark spots, known as star spots or magnetic spots. These are regions on the star's surface where the magnetic field is particularly strong. These regions are cooler than the surrounding gas because the magnetic field inhibits the flow of hot gas from the star's interior to its surface, resulting in a cooling effect that makes these spots appear darker than the surrounding gas. The magnetic field of Betelgeuse is thought to be thousands of times stronger than the Sun's magnetic field, causing the gas on its surface to become trapped in loops or arcs, creating regions of intense magnetic activity visible as dark spots. Star spots are not unique to Betelgeuse. Many stars, including our Sun, have them. However, the star spots on Betelgeuse are particularly interesting because they are much larger and more numerous than those on the Sun. The spots on Betelgeuse can be several times the size of Earth and cover up to 20% of the star's surface. The presence of these star spots also affects Betelgeuse's brightness, as they cause it to fluctuate over time. This is because the spots are cooler and emit less light than the surrounding gas. As the star rotates, these spots move in and out of view, causing the star's overall brightness to change. Betelgeuse's pulsations also play a role in these brightness variations, as the star expands and contracts, causing the spots to move in and out of view. One of the most fascinating aspects of stars is their constant change. While Betelgeuse, often called Betelgeuse, is unique, it's not the only star of its kind. There are others in the universe that share similar characteristics, making them just as captivating. One such star is Antares, a red supergiant located in the Scorpius constellation. Like Betelgeuse, Antares is a variable star, meaning its brightness changes over time. Antares is about 10 times more massive than the Sun and has a radius 700 times greater. It's safe to say that Antares, like Betelgeuse, is not a shrinking violet. Another star often compared to Betelgeuse is Mu Cephei, also known as the Garnet Star. Located in the constellation Cepheus, Mu Cephei is one of the largest known stars, with a radius around 1,500 times that of the Sun. Like Betelgeuse and Antares, Mu Cephei is a variable star and is among the brightest stars in the Milky Way. While Betelgeuse is unique in its own right, stars like Antares and Mu Cephei are equally fascinating. Each star has a distinct set of properties and characteristics that make it stand out, and studying these differences is captivating. To explain these differences, we can use our Sun as a point of comparison. Although Betelgeuse, Antares, and Mu Cephei are red supergiants, they each have their own qualities that set them apart. One key difference is their size. Betelgeuse has a radius approximately 1,000 times that of the Sun, while Antares' radius is around 700 times that of the Sun. Mu Cephei, on the other hand, is much larger with a radius about 1,500 times that of the Sun. Another difference lies in their brightness. Betelgeuse is one of the brightest stars visible in the night sky, with a luminosity that fluctuates between magnitudes 0.0 and 1.3. Antares follows a similar pattern but can occasionally become slightly brighter. Mu Cephei, however, is far brighter, with a luminosity ranging between magnitudes 3.4 and 5.1. The mass of these stars also varies. Betelgeuse is estimated to have a mass roughly 11 times that of the Sun, while Antares is believed to have a mass around 15 times that of the Sun. Mu Cephei, however, is much more massive, with an estimated mass of around 30 times that of the Sun. Each star also has its own unique behavior. As we've mentioned, Betelgeuse is known for its pulsations, which cause its brightness to change over time. Antares is surrounded by a massive cloud of gas and dust, which may help explain its erratic behavior. Though it's brighter than Betelgeuse, the surrounding dust clouds keep it from appearing as bright. Meanwhile, Mu Cephei is known for its extreme luminosity, making it one of the brightest stars in the universe. However, it doesn't show the same level of variability as Betelgeuse. Now, while we've covered the differences in their behavior, one thing remains constant across these stars: the possibility of a supernova. A supernova event may seem extraordinary, and it is, but it's actually a natural part of a star's life cycle. When a massive star like Betelgeuse reaches the end of its life, it can no longer sustain the nuclear reactions that keep it shining. When this happens, the core of the star collapses under its own gravity, triggering a massive explosion known as a supernova. During this explosion, the star can shine as brightly as an entire galaxy for a short time before disappearing into the cosmic background. This explosion releases an enormous amount of energy, which can be detected across the universe by telescopes and other instruments. But what if Betelgeuse were to go supernova? How would it affect us here on Earth? Fortunately, Betelgeuse is more than 600 light-years away, so even if it were to explode, we wouldn't be in any immediate danger. In fact, it would likely be a spectacular sight to witness from Earth. However, there are other potential effects to consider. A nearby supernova could emit a burst of high-energy radiation, known as gamma rays, which could temporarily strip away part of Earth's ozone layer, exposing us to higher levels of ultraviolet radiation from the Sun. This could have serious implications for Earth's environment and climate, though the likelihood of this happening is relatively low and depends on the specific details of the supernova event. Regardless, astronomers are keeping a close watch on Betelgeuse and other stars in the final stages of their lives to better understand this process and its potential impact on our galaxy and beyond. As we continue to explore and study the universe, we are constantly learning new things about the stars and other celestial objects that fill it with wonder and intrigue. Betelgeuse is just one example of the complexity and diversity of the universe, and each new discovery brings us closer to understanding our place in the cosmos and the role that stars like Betelgeuse play in shaping its history and future. The potential supernova event of Betelgeuse has fascinated astronomers and scientists for years. While it's impossible to predict exactly when such an event will occur, studying stars like Betelgeuse helps us understand the life cycles of massive stars and the processes that lead to supernova explosions. These explosions are not just spectacular cosmic events. They also play a crucial role in the evolution of the universe by dispersing heavy elements formed in the star's core throughout space. These elements are essential for the formation of new stars, planets, and even life itself. The study of supernovae is not just about understanding the mechanics of stellar explosions. It also sheds light on fundamental questions about the origins of the universe. Supernovae serve as giant cosmic markers, allowing astronomers to measure distances to distant galaxies and study the expansion of the universe. By observing supernovae at different stages of their evolution, scientists can piece together a timeline of cosmic history and gain insights into the forces that shape our universe on the largest scales. Looking to the future, advances in technology and observational techniques promise to reveal even more about supernovae and their role in the universe. Telescopes like the James Webb Space Telescope, JWST, and the upcoming Giant Magellan Telescope, GMT, will provide unprecedented views of distant stars and galaxies, allowing astronomers to study supernovae in remarkable detail and clarity. In conclusion, while Betelgeuse's potential supernova captures our imagination and raises questions about the vastness and complexity of the universe, it also serves as a reminder of the dynamic nature of stars and the ever-changing cosmos. By studying stars like Betelgeuse, astronomers continue to push the boundaries of our understanding, uncovering new mysteries and deepening our appreciation for the wonders of the universe. As such, the study of Betelgeuse and its potential supernova is not just a scientific endeavor, but a journey of discovery that enriches our understanding of the cosmos and our place within it.